Hi everybody, welcome to Digital Tech Join. In this video I'm going to explain and teach about the basic structured query language using Microsoft SQL Database. Now this course is for somebody who have basic knowledge on SQL and have not started using Microsoft SQL Server Database to create a database and write query languages to retrieve the records. Now let's get started. Before we move on to the hands-on, I could like to go through some of the slides explaining the basic concept of database. So what is a database? A database is nothing but a collection of structured information or data stored electronically in a computer system. Today every application, whether it is an airline booking system, whether it is an invoicing system, or whether it is a machine learning or artificial intelligence system, every system will require data to be stored and retrieved. Without data or without repository, without information, the application is of no use. So database is nothing but a collection of records stored electronically in a database system. Now there are different types of database. Some of the core and essential database are listed. So we'll go through each and every component. The first database system is Relational Database Management System. So what is a Relational Database Management System? This database is based on relational data model which stores data in the form of rows and columns together in an object called tables. A relational database uses SQL for storing, manipulating as well as maintaining data. For example, the most famous relational database management includes MySQL, Microsoft SQL Server Database and Oracle. So we are going to use in this session Microsoft SQL Server Database. Then comes a cloud database. Now what is cloud database? Cloud database is nothing but a type of database where data is stored in virtual environment and executes over the cloud computing platform. It provides users with various features and services available on cloud for accessing the data. There are numerous cloud platforms like Amazon, Azure, DigitalOcean, which offers various formats of database storage where application can store the data in the cloud. Then comes a distributed database system. A distributed database system, unlike a centralized database, stores the data in a distributed format in the organization. These database systems are connected via communication links such that it helps the end user access the data easily. Sorry. Example of the distributed database system is Apache, Cassandra, HBase, Ignite. Further, a distributed database is divided into homogeneous database as well as heterogeneous database. Now what is an homogeneous database? An homogeneous database system which executes on the same operating system and uses the same application processes and carries the same hardware devices. Whereas in an heterogeneous database, the database system which executes on a different operating system under a different application procedures and carries a different hardware devices. A distributed database we can consider more like a modular database. Each functions in its own zones, in its own environment. Then comes object-oriented database. This type of database that uses object-based data model approach for storing the data in a database system. These data are presented in an object format similarly used in the object programming languages. Then comes a NoSQL database. Now NoSQL database is totally opposite of a relational database management system, where in a relational database it forms a basic object of tables and a method of storing the data in rows and columns. In NoSQL there is no fixed design. Data can be stored in any format. The most famous NoSQL database in the market right now is MongoDB. Now related to that, I have created 2-3 videos which I will be putting the link in the description, where you'll know how the MongoDB installation is done and how can you use ASP.NET Core and use MongoDB as a backend database. Do watch the videos too. Then comes the graph database, finally, which stores the data in an hierarchical format similar to parent-child relationship. So now, since we know the different types of database, let's move on to what is SQL. SQL is nothing but a structured query language in a programming language used by nearly all the relationship databases to query, manipulate, define, and to provide access control. Now we are going to get deep into this subject and show some practical queries and how to fetch and alter and create objects and fetch records from our database, from basically a table. There are different types of SQL. Now there is data definition language, DDL. There is data query language, the data manipulation language, and data control language. Let's know about each in detail. Data definition language. Data definition language is nothing but creation of schemas. When you want to create object, alter objects, or rename an objects. So when you are creating an object, it is more of a data definition languages. Examples: alter, create, drop, rename, etc. We'll see how this is done through a structured query language. Then comes the data query language. Obviously, this is a query language which we use to select, fetch records from a table. Then data manipulation language. Data manipulation language is nothing but issuing an update command, inserting record into a table, deleting a record. That is why the name says data manipulation language, where you are inserting, manipulating, updating, and deleting a record from a table. Finally comes the data control language, which is specially used for providing access or revoking access of a particular object from the users. So these were the different types of query language which we'll learn in detail. Now in this course I am using Microsoft SQL Express Edition. The link is provided. You can just Google Microsoft SQL Express Edition. It's free and you can download it and install in your system. And now we will get into the hands-on. Now for the hands-on, we are creating a basic inventory management system, and I'll be creating the entire database, creating the table, the design of the table, setting up the relationship, and also explaining during this course how the tables are created. And then finally we will insert some dummy records and start writing queries to fetch the records. So let's get started. So once you install Microsoft SQL Express Edition, it will be installed. You click on the link, and once you click on open the Studio Management, you click on connect, and then you connect to your instance. Now Microsoft SQL provides a very fantastic IDE where you can graphically see your database, create database, modify structure. But in this session I will be using more of structured query language to perform all the creation and walk you through all creation of the database system. So right click on the database and say new database and select learn SQL. Type learn SQL and click OK. So database is created. Now under the databases you can see there is a new database called learn SQL. Now if you click on learn SQL, you will see the various objects of this database like tables, views, and service broker, storage, securities, and database diagram. We are focusing more on this section on the tables, and since we are making an inventory system, let's design the database system for an inventory management. Right click on the table, say new. So since the inventory has products, so it will have product will have units. So let's start with the basic. Let's create a unit master. So we say unit ID, the name of the column, it's integer, unit name, and created date. When was this record created? Now we can untick allow null. We don't want null to be here, and we can set this as a primary key. If you click on the column and select the primary key. Now what is primary key? Is a unique identifier for that record. So if you have a unit ID as 1, you cannot insert one more unit name as 1 because it will create a conflict. Now in order to do an auto generation of this unique ID, you can go to the properties, click on the column and select identity specification and select yes. What will this functionality will do is that the moment you enter unit name and created date, it will automatically assign a unit ID, which will be a numerical value. So we have created a unit called the unit master. Let's call it as unit master. So we have designed this table. Now create product table. So in order to create product table, we will assign product ID, same unit integer, then product name, then description, then unit ID. Now we are creating a relationship from unit master table to product table by adding unit ID over here. So unit ID, rate, we call it decimal because we might have with 2 decimal factors, then stock in hand, integer, and reorder level, integer, purchase price, and created date. Here also product ID will be unique, so we set it as a primary key, and we define we set the identity column as auto generated ID, and then we save it. Now we don't want product name to be null, so we untick that and we say save. We name this as products. So a second table is created. Notice that how the unit ID is referred in the product table. Now we will create a relationship between these two tables shortly. Now let's go ahead and create customer table. So going to purchases product. Customer ID, customer name, email address, mobile, DOB, date of birth, address, created date, date and time. We set the primary key to customer ID and we enable auto assigning of number. We name this as customers. Then we come to the order tables. We create a new table called invoice. You can name it an order also, doesn't matter, invoice. So we say invoice ID, invoice date, and customer ID. So now here we are creating a primary key and a foreign key relation of customer ID. Notice that we are not storing the customer name, we are just storing the customer ID. And this is how we create a relationship between the tables. And this is how we maintain normalization. So we are not duplicating the record. So we are not storing the customer details in customer and also storing the customer details in the orders table or the invoice table. So that is how we maintain normalization. Okay, so the customer ID is created, the foreign key is created. We will set this to identity specification this invoice some key invoice, and now we store the purchases done by the customer in the invoice details. So we have invoice details ID. Now invoice ID, product ID. There are two relationships over here. Foreign key. These are called the foreign key IDs. So basically, this is a reference of another table which we place it over here. So there are two relationship foreign key. One is the invoice ID. One is the product ID. One invoice can have multiple products. That's what we imply out of this design. Now this. So rate. Now in this case, I am not pulling the rate from the table, because when you are purchasing, or when the customer is purchasing any product, the product details will come from the product table. However, along with the rate, however, it's possible that you might give the customer the price much cheaper or much higher depending upon the product and depending upon the condition. So that is the reason rate will not be pulled, will be pulled from the product table, but however, while you saving, it might save with the same rate, or you can alter the rate. And then finally we have the quantity. We set this as a ID and we name it as invoice details. So our basic inventory system is ready. Notice that I will show you in this diagram screen, database diagram. This is a feature of MSSQL database. In your Learn SQL, under your Learn SQL database, there is something called database diagram. Right click new diagram and say yes, and add these tables. I'm going to show you how the relationships are set up. So first is a unit master and then the product. Now if you notice, in your product table, the unit ID is there. So you just click, drag it to unit master. Now here see, the primary key is a unit master, which has unit ID, and the foreign key table has unit ID. So there is a relationship between these two tables. That means if you have some records in the product tables belonging to this unit ID, you will not be able to delete any record from the unit master because there is a constraint. However, you can bypass this constraint, which is not recommended. Okay, so if you have a unit master called box, and then you have some products where this unit ID is referred, you will not be able to delete any record from the unit master table where the unit ID is placed in the product table. Similarly, there is invoice details where you can create a relationship between the invoice ID over here with this invoice master here. Okay, and then you can create a foreign key relation between the invoice table to customer table. I hope I am clear with this concept. Okay, so let's now go ahead and insert some records in this table. Now before we go into that, I will, as I mentioned, that I will be explaining you some of the data definition queries in our database. So when I say data definition, I created all this table using the ID, right? But we can also run certain queries and create this object, alter this object, rename and drop the object using the query language. So I'm going to show you how this is going to happen. So now let's create a table using our query language, structured query language. Let's create a table. So say create table customer test, open close brackets, and define the columns you want. Suppose I want ID column, which will be an integer and which will be an identity field. and which will not be null. So it will be not null. Similarly, I'll say customer name, which will be varchar string, and which will be not null. Then I'll have mobile varchar 10 size of the field, and which can be null. So this is how I create a structured table using the data definition. If you notice and refresh, you see this table is created with the columns I defined over here. And what if I want to add a column to this table? Then I'm going to alter the table. So instead of create, I'm going to say alter table customer test, and assuming I want to add address, column address, add address varchar 200, which can be null. You select the query and you click on this link execute, or you can click the F5 key on your keyboard and then right click and refresh. You can see all these columns are added. Now you will be able to also rename the table. So if you want to rename this customer test to some other table name, I can simply use the inbuilt function called sp_rename. I say customer test and then I put the new name. So I say customer table and I select and execute. If you right click, refresh, customer table. And finally, I can go ahead and also drop the table by simply saying drop table customer table. If you refresh, the table is no more in our Learn SQL database. So guys, I showed you how to create a data definition language by creating the table, dropping the table and renaming the table back. So now let's get into the basic SQL statements and how do you create queries to fetch the record from the table that we have created and the data that we have inserted in the table. Okay, so now in order to view all the objects created or available under the Learn SQL database, there is a inbuilt query or a table that will help us to fetch all the objects available in this database, objects created by us and inbuilt objects. So select all asterisk. So all is asterisk. Select all from sys objects. Now you can press F5 or you can select the query and click F5. Since the query window has only one SQL statement, you can simply click on execute. So now this table, this schema holds all the objects created in our Learn SQL database. Now in order to filter only those objects that is created by the user, that is me and you, then there is a where condition with the filter on the X type. So select all from sys object where X type is equals to U. U means user defined. So you can see all the tables created are displayed over here. Now this is generally used in order to identify the objects in the database and what is the size of the object and when was it created, to find more about the metadata information. Now let's get ahead and I'll show you some of the functions that you can use in SQL. So the basic one is, suppose you want to do some math operations like select addition. So select is important. You can't just say 10 plus 20, 30 and click on F5. No, this will result into error. So if you want to add these two numbers, you just say select 10 plus 50 and F5. So you can see the result. Similarly, you can also select digital tech joint. So the query window is over here and the output windows is over here. So now we will use some of the inbuilt functions which we will use further in section. Now there's something called get date. So what does get date do? It fetches the current date. So select get date. So you can see the get date is displayed along with the time. Now you can format this date. Now there is something like if you want to format it, you can use the convert functionality function. So it says select convert. It takes the converting into a varchar, that is a string, get date, and then there are various parameters. Like if I pass 102, the format is year, month, and the day. Similarly, if we say 3, you can see the format is changed to having a slash. Then 5 is something like this with an hyphen. Now, in order to view this various different date formats and what are the parameters, there is a, you can search the Google. I already searched. See, so this is a table. You can select one, means this is a date, sample date format. Now, if you want a date format with month, with a month name, and then this is a date format 107. You can see November 5th, 20. So this was the query, and then we can obviously use many other queries and many other functionalities, but I purposely wanted to show you the date functionality because we are going to use it. Now let's get started with our own tables and data fetching operation, that is data query language. Data query language. First is we will see select. Now we are going to use our product table. So we will first fetch records from our product. Select asterisk, that is all from products. What this will give us is all the records in the product table. Now if you want to fetch the count of rows or records in the product table, then you use select count, open and close bracket, and then asterisk inside, and from products. So there are 8 rows. So this is how you need to fetch the product or row available in the table. Now if you want to select, when you say asterisk, it fetches all the columns. But if you want to fetch only selected columns, for example, you want to fetch product name, rate from products. So this will only give the selected columns record. Now here you can also use the alias. Now column alias. For example, when you fetch this record, you notice that the header is product name and rate. This is as defined in the table. As defined in the table columns like product name and rate. If you want to change the name dynamically, then there is something called alias, column alias we can use. For example, select product name, the actual name, and then give your name, like say my product name, and then rate, you say price from products. You see my product name and price. This is called alias. Now you can use where condition. Now in this case, when we were fetching all the products from the table, assuming you want to fetch only the product name sofa cover, which is the last product, so you can use a where clause. So select all from products, where column name, where you want to add a filter, product name, and equals to sofa cover, and close it. we get a single record. Now there is something called like keyword. For instance, if you don't know exact name and if you want to fetch the products having the name so far, then this will not work. See, because it didn't find the exact match. In order to work around or fetch the record basis the like statement, there is something called keyword or product a like keyword, that is like, and then you say use a single inverted comma and use a percentage sign and say so far, and you close this percentage. What does this query will do? It will fetch all the record where so far is mentioned, whether in the start of the character or end of the character. So you can see that we were able to fetch the record. Now if you want to fetch, you can use the same like keyword, and if you want to fetch product name starting with P, then what you need to do is we need to enter P and put the percentage sign in front of the character. So this will fetch all the products starting with P. See, got it? So we can use this. It's a very handy operator to where we can use to filter out the records according to the character matching. Now we can also use, if you look at products, you see around 8 rows. Now if you want to fetch only the top one row, okay, then you can use a query as select top one from products. This will fetch only one row. Select top one all from products. So select top one all from product, or select top 4 all from product. Now there is something called order by. So order by actually sorts the record basis in the ascending and descending order. Let's use that query as well. Select all from products. Okay, select order by product name in ascending order. By default it is ascending, so you can see. If you want to move in a descending order, so you can say descending. Now you can use the same query of selecting top 1, top 3 and use this descending to select the last record. For example, select top 1 all from products and order by product name in descending order. What this will give you? It will give you the last product. Okay, so similarly you can I've used order by clause, top 1 clause. Now in order to find the total records, I guess I've already used that query. Now let's use some functionality. Select all from products, right? Let's use customer table now. Now what if I want to only select, I want to concatenate customer name and mobile number. So there is a function, input function, select concatenate, I say customer name, okay, and so you don't have to use concatenate, you can also use customer name plus sign, single quote and hyphen to differentiate, plus sign and put some space so that, and you say mobile number, mobile from customers. So you see, you can see Peter, Rocky, Richard, Alex have also now displayed, and then you can give a column name to it and saying customer details. Yeah, you see customer. Now what if I want to print only the initials of the customer and then the name? So it should say select. So it should say select So in order to do that, I use a function called substring. So you say substring, and you say you want to use customer name, and you want to select the first character and start from the first. Okay, so this will fetch PRRA and then customer name from products. From customers. You see, so we can give an alias column to initials. Okay, so we were able to use substring. Now let's also use the date functionality. So date functions we use, a lot of date functions. So the first is, now I will show you how to use this query date function to see when, on which month the customers were created. So select customer name. So there's a function called month, and then you pass in the created date as created month alias name from customers. What this will give you? This will give you the name of the customer and on which month it was created. Now if you notice, the month is coming as numerical format, but we want to display the name of the month, correct? So how do we do this? So there's something called date name, which we can use to display the. So we copy the same query, we enter this, and now we enter date name, open bracket, and what do you want to display the name as? Display the month name. Okay, and then you say for which column? For created date column. That's it. We'll remove this. So now we'll execute this query. So now you can see June, July, August and September. So you can use this date name with a month parameter. I guess we can also use the day parameters. You can see no, so day is not this, month. You can find about these functions and what are the parameters are there by just simply, you say date, type in the keyword date name and say SQL, and you should be getting SQL server date name function, and you can see what are the parameters and what are the intervals which you can use, and with an example. Okay, so this was something to do with the date. Now there is something called we can also use as a date difference, or you can use date add. Now what is date add? Date adds is a function of SQL which adds the days or the month or the year or even the hours and minute to a parameters date function. Okay, so how do you use it? Assuming I want to add 2 months to the created date or 2 days to the created date. So I say select customer name, I say created date. Now I want to add 2 days to, or I want to add 1 month to the created date. So I say date add, you pass the parameter month, and then I want to add 1 month to the created date from customers. So you can see 1 month is added. See 7th July, August, September, and then September, then October. Similarly, you can also add day. So I say add 2 days. So now you see day, and I say 2 days. 2 days is added to is 6th and 8th and 13th and then 15th. So this is a date add function where you want to add a date. Now here also you can use various date part or function that you can pass. You say date add and say SQL and then you get a function, and you can see what all parameters you can pass. You can pass year, quarter, month, day, week. So here it's date, add month, is adding 2 months to this date. Okay, now let's go to another function of date called the date difference. So what is date difference? So it will provide you the difference in hours, minutes or months for 2 different dates. So let's take an example. We want to know what is the date difference or month difference of the customer created date and the current date. So select customer name, created date. Now let's see the difference. Date diff. We want to know in months. So we say month, we say created date, and then created date is date, and then we pass get date. Get is the current date from customers. So this will give you. So Peter was created 5 months ago, Rocky 4 months, and Alex 2 months ago. Similarly, we can take the difference of days also. So now if you click on that, so 152 days before Peter was created, 152 days back in the system. So this is a date difference function. So guys, I have shown you the basic queries of fetching from a single table, and along with that I've also created shown you some date function. Now let's get into the where we are going to use a data this was a data query language. Now we are going to use a data manipulation language. We are going to show you how to insert new record, delete a record, and update a record. So let's create a new query window. Click on the database, click on new query. Okay, so we are going to use the data manipulation language. Now let's insert one product in the product tables. So so the query will be insert into products, column name. So we won't mention the product ID because that's an auto identity column. So we say product name, description, unit ID, rate, stock in hand, reorder level, purchase price, and created date. Now we specify the columns. Now the values open close brackets, and now you see the value. Product name, digital, description, anything you can write. Rate is 100 rupees. Stock unit ID is 1. So you can also refer the unit IDs by just typing unit master. 1 is pieces, so I say 1 unit ID, and then rate is 100, then stock in hand is 100, reorder level is 10, purchase price is 70 rupees, and then created date. So either you specify the date, or you can specify the date of insert, or you can say get date, the current date. So this is how you insert a record. So one row affected. That if you see the products table, this row is inserted. Now point to be noted, not necessary that you need to provide all the columns unless and until you have marked or defined the column as not null. Okay, now in this case, if you want to pass product name, I don't have a description. I don't know whether I have marked this as null. Let me go and check. Product, right click, design. So I have said I marked it as null. So that means I can skip this. So I have to remove this from here. I have to remove this from here. So I am providing product name, unit ID, rate. Okay, unit ID, rate, and I am not giving stock in hand, reorder level, or purchase price. I can remove it. So I am giving only product name, unit ID, and rate, and created date. So product, unit ID, rate, and I don't have, so I don't need to pass in. What will happen? It will insert the row and it will set the other columns as null. You can see. So this was the method you need to insert. So I have inserted the same product, and which has got a row ID of 9 and 10. Now let's write a query to delete the row. So I want to delete the last row, which is product ID 10. So I say delete all from products where, remember always delete should have where, otherwise what will happen, unless and until you want to delete all the rows in the table, then it's fine. Otherwise, but if you accidentally don't mention where and you click or execute this query, all the records in the row will be in the table will be deleted. So delete all from tables where product ID equals to 10. So delete from, you don't require all, delete from table products where one row got, so I sure it's deleted. Select all from products. Enter. You see the last row is deleted. Now I will show you how to update it. What if you want to update the rate of the last product name digital? So either you can use the product ID or the name. So update products table set what column you want to rename, so or update. So I say rate and I say the new value of the rate is 120 rupees, and where you can update multiple columns. Why I can update a description also. Description equals to updated description, and then where clause, where product name is to digital. One row updated. If you select it, you see it's updated and even the rate is updated. Correct? Remember, I've shown you how to insert in a data manipulation language, how to insert, delete and update a record. There's also one more query called truncate table and the table name. Remember the difference between delete and truncate. Delete as a where clause, and in delete you sometimes can delete all the rows from the table. However, the number assigned, the auto generated number will not reset. So if you delete all from the products and you add a record, you will get a number 10 as a serial number. Whereas in truncate, if you say truncate table products, it will not only delete all the rows from the table but also reset the auto identity number. So once you say truncate table products and then you try to add one record, then you will get a serial number as 1. So that's the main difference, and truncate table does not follow the where clause. That's the second difference in the truncate command. So now let's move to the last section of this Learn SQL, which is joins, which is very important, where I am going to show how do you join multiple tables and what are inner joins, left outer join, right outer join, and extract and fetch records from all these tables. Now in this session I will use invoice and invoice details more, so that I can demonstrate how do you use the group it and group by clause and having clause to fetch the rows along with the numbers. Let's open a new query window. This is we're going to talk about joins. Okay, so the first join we are going to learn is inner join. Inner join is comparison between two or multiple tables where the data is matching. For example, let's take the table of products and unit master. Now we will first fetch you the record and show you unit master, and we can also use products. We can use both the queries and it will have both different outputs. So we have the unit master and we have the ID of the unit master in the product. You notice all the products are set to pieces. So let's do one thing. Let's update few products with having unit ID as 3, just for query purpose. Update products set unit ID equals to 2, where product ID equals to 9. So I have updated this record. So this becomes 2, whereas remaining 1, there is no product where we have set the unit as set. So now let's first run a inner join between product and unit master. So select p dot product name, p dot rate. Now here we are creating an alias of the table name. I'll show it to you. So basically what does this do? Select p dot product name, p dot rate from products, and we can say p. So we are basically is nothing but giving a alias to the product table, because when we are using multiple tables it becomes very difficult to write the entire product name, and it's possible that 2 tables will have the same column, so this will create a conflict. So that is why we define the alias for the table generally when we are using joins between multiple tables. So that's what I was trying to explain to you. So anyways, so select p dot product name, p dot rate, u dot unit name, okay, from products p alias inner join unit master u, okay, on what link do you want this table to be established? Basically the unit ID, because as I explained, the unit ID is a foreign key in the product table. So p dot unit ID equals to u dot unit ID. So you are able to fetch the product name, the rate, and you notice the unit name also. Now unit name is not stored in the product table, but we were able to fetch the product name, unit name basis the inner join query. So the same I will explain to you with the use of different tables, that is customer and invoice. Now if you see, select all from customers and select all from invoice. Okay, so now there is a foreign key of customer ID in the invoice table. So we say select I dot invoice date, okay, c dot customer name from invoice I inner join customer c on I dot customer ID equals to c dot customer ID. Got it? You can also show the invoice ID. So I say I dot invoice ID for better understanding. Now this is not restricted to only 2 tables. Now if I want to add one more table to it, okay, then I can do that. Okay, so there is no restriction. So if I want to add after this link is established, we can say inner join and invoice details ID on ID dot invoice ID equals to I dot invoice ID. Now this is increased because ID invoice details has multiple rows. That is why you are able to fetch all the rows from both tables. So I have used 3 tables now over here, but there's no restriction. Inner join is not restricted only to 2 tables. It can be linked inner join between multiple tables also. Now let's proceed. I hope you were able to understand the inner join. Now I am showing the left outer join. Left outer join. So what is left outer join? We are fetching records between 2 tables where the left table record matches with the right table record. For example, let us take the same table of unit master and product master. Let's take the same table query. Now we are saying select product name and the unit name from product inner join. Now instead of inner join, we say left join, or you can also say left outer join. Left join unit master where p.unitid equals to u.unitid. So what does this say? This says that ki fetch all the product name where the unit ID is matching with the unit master ID. So there were 2 records, you see, there were box and there were pieces, all the records got matched. Now this is very simple. Now let's take the same example for right outer join. Now see what will happen. Now I want to know which product, which unit master is not, which is the product where the unit master is not set. So the unit master unit contains the unit master, but no product is tagged to that unit. How do I do that? We can do that through right outer join. How? We use the same query and see the result. We say right join. Now look at the query result. See now, it fetched the product table, fetched all the rows, and it also fetched one row which has null product name and null rate and a unit name as set. So all the rows from the unit master was fetched, so and matched with the product name. Now when it did that, it did not find any product which is set, which as a binding with the unit master unit name as set. That is why this is as null. You got my point? So this is how the right join works. Now I'll show you more example of the right join. So left join is something where you say fetch me records, okay, between 2 tables and match the rows, filter the rows which is available in the left join and compare whether that record is available in the comparison or the compared table. For example, this one. Similarly, right outer join. Now let me show you one more example. Now I've shown you the inner join, I've shown you the right inner join, right left join, and the right outer join. Okay. Now let's fetch records using join and the where condition. Using join and the where condition. Now for this we are going to use invoice details example. Select. So we have select all from invoice and select all from invoice details. Now I want to fetch orders of Alex. So if you notice, we have a customer called Alex, which is ID 4, but we are going to use a name. We are going to use a like operator. So we say select I dot invoice ID, I dot invoice date, C dot customer name from invoice I, inner join. Here we are using inner join because we want to compare between 2 tables. Matching rows, customer C on I dot customer ID goes to C dot customer ID. Now we say where condition. C dot customer name, like I say Alex. What this will fetch me is all the orders of Alex. So 3 orders of Alex is fetched using this inner join and the where condition. Okay. Now if you notice the date, I can change the date format for better readability. So using the convert varchar 10 and 105 date, and we give a alias to the date column, so it's more readable. I can also use a different format which will also show September there was 1 order and October there were 2 orders. Okay, so this fetched all the customers of the order. You can also use ascending and descending clause to fetch the orders of this customer. Now let's also fetch the order details. What products was purchased by Alex? In order to use that, we'll use the same query with some enhancement. We will include the third table. So what we'll do is that now in this query we are going to use 4 tables, but gradually. So first we are going to fetch the order details. So we say here comma id dot product id, id dot rate, id dot quantity from invoice, and then we use the inner join invoice details alias name id on I dot invoice id equals to id dot invoice id. What this query will do, this query will fetch orders of Alex, but this time it will also fetch you the product ID, the rate and the quantity. Now 2 things are missing. I don't know the product ID. I am not able to understand basis the product ID. I need the product name. So what you need to do, you copy the same query again. Now here we are going to use the product name just after the product. We say p dot product name, and now we are going to include one more inner join on products p alias on id dot product id equals to p dot product id, and this will fetch us the product name. Invalid object products. Fine, great, it fetched the product name against the product ID. Now if you notice, I have one more requirement of showing the total amount. So in that case, I can use the operator function. So I just say copy this query, and then I say comma, I copy this method rate and quantity, and I just multiply, and I give a alias to it as total. I got this total amount. Okay, so now I'm able to fetch Alex orders, and I'm also fetch the values. Now I want to know what is the total value of orders given by Alex. Simple. Here I will have to use the group by keyword. And keyword. So how this will work, let me copy the same thing and paste it. I say invoice ID, I don't want the date, I want the customer. Okay, and here I don't want the product name and everything, because I want to know the total value of order. So I say sum rate and quantity, okay, as because my total, and remaining everything remains the same. But if I execute this query, it won't, because I have not mentioned the group by clause. So I'll say group by I dot invoice ID and C dot customer name, because I want to group basis these two fields. I want to fetch the total order. So yes, so you can see this is the total value of Alex, but here I still don't want, I just want one figure and which says that Alex has given this many order value. So I remove the group by ID and I just mention customer name. So this is the value of order that customer Alex has placed with us. Now let's tweak this query a little bit and say if I want to know month-wise order given by customer Alex, month-wise. So I just copy this query. Okay. And here I mention the function month and I pass I dot invoice date as month, order month, alias, and customer name, and rest remains the same. Now here I have to group this by, because I have used a select. So yeah, so now I say, so what do we get? We get September month and October month. But wait, here still I'm getting a numerical value of the month, but I'm not getting the name of the month. So as I mentioned, you can use the date name which I showed it to you. So it's a date name and you pass month and then I dot invoice date. And you copy this. October month Alex has, so this is a total value of order given by customer Alex based on different month. So guys, so I have shown you the different queries which you can run, and I've shown you how you use the data definition language, data query language, data manipulation language using a very simple design structure. I hope this video was helpful, and please do subscribe to my channel and like this video. Thank you very much guys.